If you put a scallop in molasses or corn syrup, it's not going to be able to move anywhere like it does in the water. Scallops swim in water by opening and closing their shells at a hinge. They open slowly and close fast, which makes little jets that propel them forward. But scallop theorem holds that reciprocal, time-symmetric motion will get you nowhere in a thick, viscous liquid. That's just where you do one thing forward and the same thing backward. And in order to get anywhere in a viscous fluid, you gotta move in a way that doesn't immediately undo what you just did. So this fish with reciprocal motion in glycerol doesn't get anywhere, it just wiggles. But this fish moves right along in the thick glycerol because it doesn't reverse its little flappy things. Viscosity is important because it's the divisor in a number called the Reynolds number. It also takes into account the density of the fluid, the flow speed, and the volume of the system divided by its surface. So that means that a person swimming in water has a higher Reynolds number than a goldfish. And a goldfish has a much higher Reynolds number than E. coli. So basically, water acts thick to bacteria and microscopic animals. And the same thing applies, so they couldn't get around with only 1 degree of reciprocal motion in the water. The sperm cell gets around the thick fluid scallop problem with whip-like wiggles that propagate along the flagellum. Instead of using time-reversible flapping motions like the top one, they use bending wave motions that have inherent directionality and pushes those little tryhards along.